Hey everyone, Chang here and welcome to my channel. Now this is video 2 for the series on CBEST questions. If you haven't seen those, I'm going to put a link in the description down below. I did a first video and an introduction to talk about CBEST and the questions to be expected. So we're just going to go over the second set of questions. Now, here's the thing. Once again, even if you're not taking the CBEST, take a look at these questions because the whole goal of it is not to just go over the answer, because guess what? The practice test itself has the answer, and I'm going to put a link on that in the description down below as well. But the idea is that you want to go beyond just that specific question, because if you want to be prepared for these type of questions, the best way to approach it is to not only be able to solve these questions, but ask yourself the question, what can I do to make this problem a little more complicated? What is a different variation of this problem that I could potentially encounter? Now, I've seen this strategy used a lot in schools where they would have students create problems for each other and have them solve, thinking that it will immediately boost their abilities. It's yes and no, hit and miss on that one. The idea is that you want to create a problem that you yourself can solve, that you understand the core concept of the problem itself. So don't just try to make this stupidly hard for no reason, a problem that you can't solve, or a problem that just takes a gajillion long time to do a calculation, right? That's not the purpose of it. It's to understand the core of that problem and figuring out ways to tweak it so that it does become a little more difficult, but you can still solve it. Once you start getting into the habit of doing that, you are indirectly building your skills to further understand this problem and any variation of the problem and the general topic as a whole. So let's look at this problem. I'm going to give you guys suggestions on one, how to solve it, and potential variations of these problems. So let's begin with the first one. So this problem right here is number 6, right? So remember in my first video series, I did 1 to 5. This is going to be 6 to 10. So the first one in this series, or number 6, they have this graph, which I'm hoping is at least somewhat clear in the camera, right? We have this, what they call outline of Clear Lake's shoreline. Now, for some reason, in this practice exam, they really like focusing on just perimeters. So that's what this problem is. What is the total length of Clear Lake's shoreline? So it only focuses on perimeter. As you guys can guess, there is a ton of variation you can do with this problem. First, let's solve the problem. Now, we have this outline right here, and hopefully it's a little clear, and we want to find the perimeter of it, the length of it. So what we do is we just basically count, right? We can just count the length. Well, here, that is, let's just use, I don't know if red will show up more or black will show up more. All right, so there's 2 right here. There's 3 right here, and then it's going to be, what is that? 1 right here. So you got to be careful of the size of going down, and there's 4 right here, right? 1, 2, 3, 4. 3 right here, 1, 2, 3, 4, 5, 5 down here, and then you have 1, 1, 1, 1. Okay, so what you would do is you would add them all together, right? 3 plus 1 plus 4 plus 3 plus 5 plus 1 plus 1. This is where it could get a little messy. Plus 1 plus 1 plus 2. Okay, so you can add all those up, and then a lot of us would make this common mistake and immediately think that that is our length, right? Our perimeter. Well, yes and no, right? First and foremost, let's just add them up. That's 4, 8, 11, 16, 17, 18, 19, 20, 22. Okay, now, that's cool. But the problem is that each and every one of those lines are not necessarily 1. Because if you look at the scale itself on the outside of the axis, notice that you have 1, 2, 3, 4, 5. Well, it only takes 5 of these lines to get to 10. So instead of just 1, each and every one of those lines represents 2. So in that case, rather than the standard 22, you actually have to multiply everything by 2. So it's going to be 22 times 2, which gives you 44. So the length itself in this situation is 44. All right, so we talked about how to solve this particular problem. Now, let's think about variations for this problem, right? So this is just the perimeter. So of course, with squares, right? Especially in little grids like that, another thing we can consider is that what if they ask you for the area of this particular clear lakes, right? Well, if you had to find the area, remember that area is basically our units. So what would you have to do? Well, what you can do is actually a different variation. You can break this into chunks, right? Oh, I probably shouldn't use red again. Let's see, I don't know if blue is gonna show up, but let's see. I can break this into chunks, however I want it, right? And then just start calculating areas of each and every one of those individual parts. And then afterwards, what would we do, right? We would add them all together. Plain and simple. So that's one potential variations, right? Of course, you can have various way of solving areas. You can actually make a large thing and then start taking away areas that actually might be easier instead of breaking up the inside. But think of that as a way to approach this problem, not just to solve it, but what can you do to make this a little more challenging? So I'm not going to give you the answer to this, but then what happens if the question was a little different? What if we ask, what is the area of clear lakes? And just try to solve it. All right, so this is problem number 7. 2 in this video, number 7. Yes. All right, cool. All right, so this one is a very similar problem. Once again, it's talking about perimeter. Luckily for us, if you notice, the problem itself actually just mentioned the word perimeter, so you don't have to guess based on the wording of the problem and all that stuff. We know exactly what it is saying. Now, it has a picture view, right? But now here's the thing. This is a top view, and it can get a little confusing if you skim through the problem very quickly and just miss the key detail. But basically, let's just talk about it. A glass table is supported by a rectangle pedestal. If the tabletop is 8 inches wider than the pedestal on each side, what is the parameter of the glass table itself? So that's basically what it's saying. If you look at this is the top view of the table. If you're looking at the table, you're staring down at it. So basically think of it as you have that panel of glass, and then you have basically your pedestal right there. And then it's saying that each and every one of these are 8 inches from the pedestal itself. Hopefully that made it clearer and not more confusing. But basically, once again, we're just trying to find the perimeter of the glass table. So what can we do? Well, we know that right here, this rectangle on the inside, if I shade it, right, that is just basically your pedestal right here. Okay, everything else is glass as well. So it's glass on top of the pedestal, of course, and then everything else on the outside. So we wanted to find the perimeter. All we have to do is just find this larger, I guess you could say, rectangle. So let's think of it this way. This is 36, and we know it's 8 on each side. 8 right here, and 8 right here. So that's 16. So 36 plus 16 was that. That's 46 plus 6 again is 52, right? So we have 52 on top, and the bottom should be the same. It's a rectangle, so we have plus 52 again. And then now we have the sides, right? We have 48, and then we have 8 up here and 8 down here as well. So in that case, it's going to be 48 plus 16. What is that? That's 58. That's 64, right? So plus 64 plus 64. So there it is, right? To find the perimeter, you have your 4 numbers, and all you have to do is add them together. Well, this one is 104, this one is 128, and then you can add these guys together. That's what, 232. And just like that, you've found the perimeter. Now that was easy, right? That's not too bad. So, once again, you know what I'm gonna ask you now. What if it wasn't asking for just a perimeter? What if it was asking for the area? And better yet, not just the area of this thing, right? What if it just wants the area of glass that is not touched by the pedestal? Oh, there you go, right? That's a complicated one, because that means you're just finding that little strip right here, right? So how would you solve a problem like that, right? Just incrementally make it a little more challenging, right? All right, so we found the perimeter of the outside. Well, if you want, you can find the perimeter of the inside. All right, now we're gonna move on to area. You wanna find the perimeter or the area of the inside? Yeah, that's fine. Area of the outside, that's fine. All right, well, what if they ask you the area of the strip? Can you do that? If you can, then you most likely have gotten this problem completely mastered. All right, problem number 8, or problem number 3 in this particular video. So this one's a fairly simple one, right? Rob uses 1 box of cat food every 5 days to feed his cat. Approximately how many boxes of cat food does he use per month? Now, this is more of a sort of ratio estimate kind of problem. I want to say it's more ratio than estimate. The idea is that if you know it takes 1 box of cat food, right, every 5 days, well, now we just need to understand roughly how many days are in a month. Now, of course, you have your standard, there's potentially 31 days, there's potentially 30 days, and there's potentially 29 days and 28 days, depending on, don't be, I guess you could say, super technical about it. Just about average, it's about 30 days, right? So just go with that. So that makes our lives a lot easier because you're just approximating anyways. And if I remember correctly, the multiple choice of this problem is that they give you potentially I don't know, I don't remember exact number, 2, 4, 6, 7 boxes, whatever, right? The idea is that it's whole boxes, right? Don't get into too much technical details of trying to find a fraction of a box, none of that. So 1 box is 5 days, all right? If we think it's about 30 days in a month, all right, 30 days, how many boxes, right? Fairly simple. Well, guess what? We can go step by step, right? 1 box equals 5 days, 2 boxes equals 10 days, 3 boxes equals 15 days, so on and so forth. Or we can just figure out what is the number that multiplies 5 by to get 30. Well, 6, right? So it's a ratio problem. So that's the same thing, right? So if 1 box lasts you 5 days and you need 6 times that amount, well, 6 times, then you probably need 6 box, plain and simple. And of course, you can use cross multiplication or whatsoever to solve this problem as well. So this is a fairly simple, just ratio estimate problem, right? And then of course, you can make this more complicated. What if it's not a month? What if it's several months? What if it's a year? So on and so forth. But honestly, this one is just a standard ratio problem. Know your cross multiplication if you feel like that will help, or know that it just basically incrementally increase, or just be able to find the numbers that multiply, right? In this case, you have 2 given numbers, 1 unknown and 1 given. This one, what is the number that multiplies to get from 5 to 30? Then you find the other one. Plain and simple. So there's a lot of variation of this problem. All you have to do is just practice this kind of problem. Luckily for us, ratio problem can't really get all that much complicated. It's always going to fall under the lines of something similar to this. What was that phrase? Speak of the devil and he shall appear. Right, there it is. Right, look at this problem. Tara can develop 2 rolls of film in about 18 minutes. At this rate, how long will it take for her to develop 8 rolls of film? Another ratio or rate problem, depending on whatever you want to call it, right? So there it is. Another one. The structure is the same, even though the problem seems slightly different, right? The idea is that they give you 2 things. The first one is 2 rolls of film in about 18 minutes. Now you want to know 8 rolls of film. How long is that going to take? So let's just write this out. 2 rows, 18 minutes. Okay, and then you have now 8 rows. How many minutes, right? And once again, you can always increase it to get as close to 8 as possible, or all the way to 8, right? You can double it, right? If it takes 2 rows, 18 minutes. If you want 4 rows, well, you times this by 2, that's 36 minutes, so on and so forth, right? Of course, you can always go with the standard. All right, well, 2 times some number gives you 8. Hopefully, this is not too much of a surprise, right? So that means if I were to multiply this by that same number, what would that be? 18 times 4 is 72. 72 minutes. Now, the only caveat that I can see them making this slightly more challenging is that if they keep it in minute, that's fine. Most of the times they probably want it in like specific hours or so on and so forth. So then you just have to convert this into hours. So that means, well, 72 minutes. Hopefully you guys remember 1 hour is equal to 60 minutes. All right. So in that case, this is just going to be 1 hour and 12 minutes, right? And I don't think they will ever do this, but then of course, some people are just jerks and they can. If they want it in some sort of decimal format, you can figure out in decimal format. You would just have basically 12 minutes divided by 60, and then, well, that's 1 over 5. So it's going to be what, 0.1, right? So there it is, right? No, 0.1, what am I talking about? 0.2. Okay, so there it is. This is how you would solve it. 72 minutes, and then if they want you to convert it, 1 hour and 12 minutes. If they want you in decimal, go with that, but most likely they won't, right? So notice that the structure overall is the same. It's just another variation of your ratio rate problem, right? Doesn't get any more complicated than that. All right, so we have a very long-winded, long-worded problem that took me a while to write. Tiring much, right? Now, here's the thing. I don't know why. There's this weird fascination with marbles and cards and dice. So, here's my not 100% accurate, not 100% effective strategy, but if they are talking about bags of marbles, they're talking about decks of cards, or they're talking about some form of a dice, most likely they're talking about some form of probability. Okay, so this one, here it is, a bag of marbles. And luckily for us, once again, it talks about probability, so you don't have to guess in any way. But most of the time, yeah, it talks about probability. It's probably going to use bags, cards, and dice. Okay, so let's talk about this. Liliana has a bag of marbles. The bag contains 18 black, 15 red, 11 blue, and 8 white marbles, right? Liliana randomly takes a red marble from the bag and leaves the marble on the table. What is the probability that she will take a red or a white marble from the bag? So, I mean, I don't know. People don't even play with marbles anymore. So, let's talk about this. All right, first and foremost, the caveat, the trick of this is the fact that she took one of the red marble out of the bag already. So even though the bag originally contained these numbers, right? The actual bag that she's going to be pulling from now doesn't, because she took one of the red one out. So the number itself, actually, we have 18 black marbles, right? And then instead of 15 red, right? Remember, she took one out already. So now you have 14 red marbles, right? And then you have 11 blue, still the same. And you have 8 white, still the same, right? There it is. All right, cool. So this is the total population inside the bag. So you just have to add these together. What is that? That's 32. 32, that's 43. 43 and plus 8 is going to be 51. So there's 51 total marbles in that bag, right? Now, the question itself, what is the probability that she will take a red or a white marble from the bag? So, this is our red. Where is it? Right here. And our white. So, if we add those together, right, what do we get? We get 22, right, over our total population. There it is. That is our probability. Remember that for a probability, in order to find it, it's always your desired outcome over the total population or the total amount, right? So your desired one is either a red or a white. These two, add them together, that's your desired. And the total population, everything that's available at the bottom, which is 51. So that's how you find this probability. Of course, there is so many variations that you can do with this kind of problem. It can get super complex. But luckily for us, the CBEST exam, they're not going to get super complex with this, right? You can ask situations like what happens if you put the red ball, she draw one and put them in and then draw another one, right? There's just a ton. I've done a whole video on different probabilities that you can check out just to beef up your skills on basic probability. But understand that most of the time that they're talking about probability in terms of just the CBEST exam, and most likely in regular SAT, ACT, right? It's not going to get super complex. It's usually something along the lines of this. The only caveat is be careful of a situation when they're talking about deck of cards. That's the one that can get a little more tricky, because guess what? All of a sudden when they're talking about, oh, what is the probability of her drawing this specific card, like what is it, a jack of hearts or something like that, right? Then all of a sudden they're talking about red and black suits, right? Or different kind of, I guess you could say, face cards, so on and so forth. That's when it can get more complicated. But this one, there's no mix in it. There's either a red marble or white marble that they want, and then there it is, right? So that is our probability problem. All right, so there you have it. Another 5 problems down the drain, right? Once again, this is for the CBEST exam. This is problem 6 to 10. Now, hopefully with this, you guys realize that a lot of these problems are fairly simple. Try to make it more complicated if possible, right? And not just make it complicated for the sake of being complicated. Make it complicated so that you still truly understand the core of the problem, but at least put a little twist on it just to further build your understanding, right? The other thing I'm hoping that you guys would get from this series of videos is that by going through many problems, because as you guys can see, right, a lot of the topics will end up repeating itself because it's a freaking 50 question test, right? You will see the basic structure. Just from experience itself, you already can see, just by reading the problem, you know what it's asking. And when you know what it's asking, you know how to solve it. So that's what I'm hoping with these video series. Yes, a lot of them are word problem, a lot of them are very long and kills my marker like crazy, but it is worth it. Hopefully you guys enjoy it as well. If you haven't already, please like, comment, and subscribe. I will see you in the next video.